Okay, so parabolas. So this is section 10.2. 10.2 kind of introduces the idea of the conic and then goes into parabolas. And so I'm just focusing on like the parabola part. So you have seen parabolas prior to this course, or you should have. Maybe you don't remember it, but they do show up in algebra in general, before pre-calc. College algebra does cover parabolas in detail. And so we have standard form, which is ax squared plus bx plus c. And that's the form we use when we're solving quadratic equations. We factor to find the intercepts. And then we've got vertex form, which is a, and then in parentheses, x minus h squared plus k, where h and k is the vertex. And you can find the vertex if you don't have it in vertex form by knowing that h is negative b over 2a. So when we're in algebra, we basically have two forms that we're looking at, standard form or vertex form. And we really only ever care about the vertex of a parabola or like the intercepts, whether it opens up or opens down, and that's the value of a. If a is positive, it opens up. If it's negative, it opens down. And then the axis of symmetry is basically the middle of your parabola where the vertex is. Now, college algebra focuses on functions. And so it is all about everything we do being a function. So we only look at functions and parabolas in this lens where it's either up or either down. But that's basically half of parabolas. We're missing a whole nother world of parabolas that comes when you're actually looking at conics. So when you're looking at it as a conic, you're looking at it from the view of geometry as a shape. And so if you're looking at it as far as a shape, the fact that it's a function where each input has only one output doesn't matter because it's an actual shape. And so there are things that are parabolic that may not be functions. And that's essentially, if we're trying to graph it, it's like tilted on its side. So when we study parabolas in algebra, we're basically only studying half of the world of parabolas because we're looking at just the functions. We're ignoring this other type of parabola, which comes about when we're looking at conics. So when you look at it from this other lens, so as a function, the definition of a parabola is basically given by the equation y equals ax squared plus bx plus c. But when you're no longer looking at it in terms of having to be a function, we have to look at the parabola from a different definition because now we don't have a single equation that we could use to define a parabola because it's not always in that form. So we instead have a definition that's more related to geometry where we're talking about the distance things are away from each other. So that's more of a geometry standpoint. So a parabola is the set of all points in a plane that are equidistant from a fixed line, and that fixed line is what we call the directrix, and a fixed point, which is called the focus. So basically, the distance, if you have a point on the parabola, the distance that point is away from the focus is the same distance it is from the directrix. So when we've got this image, wherever your point is, these distances, it basically always kind of forms sort of a, well, it's not even really a square because you're got different angles, but that distance from the focus is the same as the distance from the directrix. So other types of conics that we will study, like the ellipse and the hyperbola, also talk about equidistance, but they're looking at like the sums of the distances, or they're looking at the difference of the distances. So when you're looking at this the conics, the definitions are very similar, but a parabola, we're saying those two distances are equal. And then those other types, you're looking at the sum are the same or the difference is the same. So when we define a parabola in terms of a conic viewpoint, it's not in regards to the equation at all, what the equation looks like. We're looking at the distance points are from certain things that we've named, the focus and the directrix. So we still have a vertex of a parabola. So that is still, the vertex is still what the vertex was when you learned about parabolas in college algebra. But we have a different definition for it. We're not looking at it as negative b over 2a because that formula, ax squared plus bx plus c, doesn't apply to every parabola. It's only those that are functions. So instead, we define the vertex as basically the halfway point between your focus and then your directrix. So it is, if you were to draw a line between your focus and then that directrix, which is basically a line, your vertex is in the middle of that. And then the axis of symmetry is still going through the vertex. That part is still the same. So we have to define things differently when we're no longer restricted to functions, because our previous definitions only applied in certain cases, only applied in the case that it was a function, and it doesn't necessarily apply when it's not a function. So we've got new vocabulary that we're looking at here. And when you're dealing with parabolas from the conic viewpoint, I always draw a picture and I always label and kind of think where's my focus, where's the directrix. And the thing that I always, to help me remember, is that your parabola is curved around the focus. So the focus is kind of on the inside of your curve. And then the directrix is flat on the outside. So your parabola is curving away from the directrix. So it's pointed in the opposite direction of the directrix. So you can see if the directrix is horizontal, it's curving up away from it. So that's just how I kind of think about things. So that way, when I'm trying to draw what these parabolas look like, I can think about where am I, if I'm given a focus and a directrix, I can kind of think about where is my parabola actually shaped according to these things. So when we're looking at conics, we have standard form, but it doesn't look like the standard form when we're talking about parabolas in college algebra. So I call these conic form because that way it doesn't get confused with what we were calling standard form, the ax squared plus bx plus c. But our book does call this standard form, but I call it conic form because this is through the lens of a conic. And these are the equations that I want to see you use in the homework, because this is what you're learning about this week. You're learning about these particular equations and these properties. You're not learning about what the type of equations you learn from college algebra. So I'm expecting these equations to be used, whether it's vertical or horizontal. So vertical is talking about the axis. So for vertical parabola, that's a function. That's the same type that we learned in college algebra. Your axis of symmetry is vertical. Horizontal, it's tipped on your side, and now your axis is a horizontal axis. So the formulas are very similar. We still have H and K for your vertex. So we're not changing that the vertex is given by H and K. So at least that is still the same. We still have something squared. The vertical parabola is very similar to vertex form of a parabola. You've got x minus h squared. So that's the same as vertex form of a parabola when we studied it as a function. When it's horizontal, now the squared part is y. So instead, now it's going to be y minus k squared. So you can kind of see similarities between these. Then the right side of the formula is where things get different, because we have this 4p times y minus k. And then it's 4p times x minus h, the other part of your vertex, essentially. So p is part of the formula, and p is the distance between your focus and the vertex. And because the vertex is in the middle, it's also the distance between the directrix and the vertex. So that distance, the distance between our focus and the directrix is basically 2 times p, because it's p in either direction there. So we give our formula for a parabola in terms of this value p. And so you're going to want to reference these images, and these are coming directly from the textbook, because when you're given, if you're given various information, you're trying to find p in order to determine your formula for the parabola. And so how you find p depends on what they give you. If they give you the directrix and the vertex, then you can find p that way. If you are given the focus and the directrix, then you can find p by knowing that the distance there is 2p. You could be given the vertex and the focus, and then you need to find p, but you need to find this value of p regardless of what you're given, because that's part of the formula. So that's what I'm expecting to see like on the homework, because, you know, we're looking at you to use this version to really show that you understand this version. So the formulas, like the vertical parabola on the image, you see, basically we've got the upward or the downward. The only difference there is the sign of p. So it's very similar to the sign of a, where if a is positive, it opens up. If a is negative, it opens down. Basically, p is the same sort of thing. It opens up or it opens down. And then in the horizontal, the positive version opens to the right towards the positive numbers on the horizontal axis, and a negative opens to the left. But very similar. I would just use these for reference. The formulas for the directrix are going to be important. So I'll get my highlighter. So the directrix for a vertical parabola is y equals, and then it's k minus p. For the horizontal, it's x equals h minus p. So you'll need that information. Other things that you may need are these formulas for the focus, where it's either going to be h plus p or k plus p. That kind of helps you find what p is when you're trying to solve here. And sometimes you're not given like the focus of the directrix. You might be given another point on the parabola, and then you have to solve for p another way to figure out what that is and then get your formula. But these are going to be good references for you, and you're going to be, you know, coming back to this quite a bit. So are there any questions before I start going into examples? Okay. Well, so I've got tons of examples. I think I have 8 total. We'll see how many we get through. I wanted to try to give an example of every possible thing that you could see with parabolas, the different types, the information you might get, and how you get the formula. So I'm going to be referring back to that previous slide a lot, because it's just a great reference. So we'll start here. We have a graph. And so we're going to assume that the vertex is through the origin based off of the picture. We're not told, but the vertex is going to be along the same axis as our focus. And so it looks like it's right through the origin there. So I'm going to just label that our vertex is going to be the origin. And then we've got our focus, negative 4.5, comma 0. So we want to, now I'm using standard form here because that's what our textbook uses, just to be consistent, but we're using the conic form because that's the formula we want to practice using. So first you have to say, okay, is this a horizontal or a vertical parabola? So this one is a horizontal parabola because it's opening along the horizontal axis. So you want to use your horizontal parabola formula. So it's y minus k squared equals 4p times x minus h. So y minus k squared equals 4 P times X minus H. So we know what H and K are from the vertex. So the vertex always is H comma K. So since it's 0, 0, we can just replace those values with 0. So really what we have, we're going to have y minus 0 squared, or just y squared, equals 4p times x. So I always start by getting the form of the equation that I need, plugging in what I know, and then your next step is to find p. And so we need to do that using the focus. So I'm going to go back to this slide again. And this is where we're using this ordered pair here, that the focus is H plus P comma K. Or you could literally find the distance between your focus and your vertex, but I just usually use that, what I have here, H plus K. So that tells me that negative 4.5 is equal to H plus, I think I said H plus K, I meant H plus P. So we know H is 0. So that tells us our P is negative 4.5. So all I need to do now is plug that in for P to get my formula. So I'm going to go back over here. So I have y squared equals 4 times negative 4.5 times x. And so we get y squared equals negative 18x. So that is the form of our parabola. That is the equation for this parabola. And you can do this in Desmos. You can check your answer in Desmos. I strongly recommend that you do that. Just especially on this week's homework, I've seen a lot of people get equations, but they don't actually go through the correct points. So that's what I recommend, checking your work in Desmos. So the way that I check my work is I will put in my ordered pairs that I know I have to go through. Whoops. And then I will even just kind of label them to make sure that I have those labeled. Now I don't go through the focus, but I just want to make sure that's in the right location, according to my parabola. And then I can just type in our formula, y squared equals negative 18x. So you can see that it is going through the vertex and it's opening in the correct direction for our focus. So it looks good. We don't have any more points to kind of, double check it, but it does look the same as this graph that we have here. So looks correct. So I would use that as a check. Are there any questions so far? Okay, so let's look at one where we've got the vertex not at the origin, because the origin is the easiest case to deal with, and it's not always going to be at the origin. So here, this is a vertical parabola. This is your normal type of parabola that you're used to seeing. So we've got the vertex at 2, 6, and then the focus at 2, 4. So even though that these are on the image, I like to write down all of the information that I have and make sure that I don't switch signs. So our vertex is H comma K. So I can label that. So I know that H is 2 and K is 6. So this is a vertical parabola. So the formula is x minus h squared equals 4p times y minus k. And you want to be very careful that you are writing the formula correct, because when I was preparing for this today, I kept reversing my h's and my k's. I kept reversing my x's and y y's, even though I know what the formula is. It's always good to double check. And I would catch it when I was going through it. I'm like, that doesn't make any sense, but it's really easy to just accidentally write the wrong thing. So, I would say just double check, go back to your reference and make sure that you've written the formula exactly as it should be for the type of parabola that you have. So I'm checking here, vertical parabola, x minus h squared equals 4p times y minus k. So that's what I wrote down. The other thing that I'm going to grab from here is the focus, because we're given focus as the other point. So I really care about this h comma k plus p thing. So I'm going to grab that and write that down as well. So this is h, and then this is k plus p. So that information is going to be needed so we can find out what p is. So I can start by plugging in my values for h and k into my formula. So I have x minus 2 squared equals 4p times y minus 6. And we still need to find p. So I'm going to go to this other part here where I have k plus p. So that's going to be 4 is equal to k plus p. And k is 6. So I have 4 equals 6 plus p. And then we just have to solve for p. So we're going to subtract 6 from both sides. And that gives us negative 2 is equal to p. And you want p to be negative here because we're going down. So you can kind of double check that you've solved correctly by the sign. Since it's opening down towards the negative numbers, our value for p should be negative. So once you've got that, then you just plug it back in. So we've got x minus 2 squared equals 4 times negative 2 times y minus 6. And so we get x minus 2 squared equals negative 8 times y minus 6. And we generally do not distribute or FOIL or do any of that stuff. We leave it in this form so that way we can see clearly what the vertex is. So you don't need to do negative 8 times y or negative 8 times negative 6. You don't have to solve for y to put it in your typical form when you were looking at it in college algebra. We don't have to multiply out the x minus 2. You can leave it in this form. That's really what the standard form is. The only real math you have to do once you plug it in is to multiply your 4 times p. Any questions?
Can we type that in Desmos?
Oh, yeah, sure we can. So let's see, I'm going to change my vertex here. And to 4 for my focus. And then we had x minus 2 squared. Oh, help if I actually, I thought I was trying to highlight it, would all delete. It did not do that. X minus 2 squared equals negative 8. X minus 6. So we've got our vertex. It is opening towards the focus, which is good. And it looks like it's sitting here about 5.5. That looks about right. right here on our graph. So, you know, you can line it up. It does look accurate. Other questions?
Stephanie, there's a question on the homework where you're looking for a point on the parabola. It's a really small parabola. We obviously I got the main parabolic function in there, and then I could find the point. Are you going to cover an example where we might try to find a point? I'd like to kind of go over that if we could.
No, I'm not going to cover for here. I'm covering on getting the equations for the parabola. I'm not going to be covering like once you have the equation, how to find a specific point, because that's just you just plug in a number. The bigger part is getting your equation correct, because if your equation is correct, then all you need to do is plug in whatever your x or y is, and then you just solve for the other answer. There is a video that should go through applications of these. Let me log back into Blackboard. It's taking a while.
It's no problem. If it's a video, I'll go back through and look, but I found the point based on my graphing, but I was just wanting to double check it.
Actually, I did not have a video on applications, so that is something that I can make a note of to do later. But yeah, you're basically, once you get your equation, you just, whatever your value is that you need to plug in, you just plug it in and solve for the other.
Okay, that's kind of what I did. I just wanted to know if there's another way to check it. Thanks.
Oh, other than graphing and then looking at your graph, that's the only other way. So that's probably problem 2 that you're talking about on the application assignment. Okay, well. Other questions? Okay. So here's one where we don't have a graph, so you're just given points. So we want to find the equation. We've got the focus, which is at 0, 3/2, and then the vertex is at the origin. So vertex is at the origin, so that's going to be 0, 0. And then the focus is at 0 and 3/2. So we have to decide whether this is going to be a vertical or a horizontal parabola. Because you can't, you know, until you decide that, you don't know which of the 2 equations to use. And so the way that I always draw a picture to help me decide what the parabola should look like. So I'm going to just kind of sketch, and we've got a vertex at the origin. And then our focus is at 0 and 3/2. So that would be like right here. So the parabola always kind of curves around the focus. So this tells me that my parabola needs to be curved something like this. Okay, so I'm not drawing exactly through the, not the best drawing. It's not actually going through my vertex, but I'll try it a little better. It's going to be curved around this focus because it has to, the curve faces your focus. So this tells me, once I figure that out, this tells me that I have to have a vertical parabola. So that tells me which of the 2 equations that I'm going to use. So that will be x minus h squared equals 4p times y minus k. So if you draw your picture wrong, then you're going to have the wrong form, the wrong equation, and then everything from that, is going to be wrong. So that's one of the most important things, especially this week, is to make sure you are drawing a picture so that you know what it should look like and if that makes sense. So we've got our form here and we've got our vertex at the origin. So that means H and K are 0. So this will be x squared equals 4p times y. So we need to find what p is. And so I'm going to go back to our picture here. So P is the distance between your vertex and the focus, which when the vertex is 0 is actually really easy to solve. But I always look at that ordered pair that we're having. It's K plus P from that focus. So this 3/2, that is equal to K plus P. And K is 0. So P is equal to 3/2, which makes sense because P is the distance from the focus to our vertex. And so if the focus is at 3/2 up there and the vertex is at 0, that distance is going to be 3/2. So you just plug it into your formula. So we have x squared equals 4 times 3/2 y. And this gives us x squared equals 6y. So we can pull up Desmos to double check, make sure everything is in the right spot. I got my vertex, I've got my focus, and then my formula, x squared equals 6y. And so that matches the drawing that I had, assuming that your drawing is correct, then you can kind of check yourself. It's a little harder if you have to make the drawing yourself to make sure that you have it right, because you have to trust that you have the correct drawing. So then it's focusing more on, okay, if I'm given the focus and the vertex, does it have the right shape where it needs to be? Like when I was first doing this problem just on my own in my head, for some reason, I was thinking it was 3/2, 0. I had my X and Y mixed up in my head. And so I had the wrong formula. I wrote for a horizontal versus a vertical parabola. And then you would see that, wait a minute, it's not hugging the right spot. So in my case, I had it going this way when it was supposed to go this way. So my focus was not in the right location. And that kind of tipped me off that, oh man, I reversed my X's and Y's. So you can use it to kind of sanity check, but that is, again, assuming that you have your drawing correct. Are there any questions? Okay, so here we want to find the equation again. We've got the vertex at 1, -8, and then the focus at 3, -8. So, I'm going to just start by rewriting what I've got here. So the vertex, 1, -8, focus is at 3, -8. And so we have to decide, is this going to be a horizontal or a vertical parabola? So I want you guys to think about that, maybe put in the chat or answer out loud. Do you think this one is going to be horizontal or vertical? Because that's the most important decision to get right, is which of the two you need to use.
Horizontal,
Okay, so why do you say horizontal?
because it's going that way.
So when I plot my points, so let's say 1, -8 is somewhere down here. I don't need to put them exactly where they, and then I've got 3, -8. So the vertex hugs the focus. So that means, yes, it's going to be horizontal. I have to open towards my focus. So for a horizontal, our formula is y minus k squared equals 4p times x minus h. So our vertex gives us our h and our k. So we have y minus -8. So that becomes y plus 8 squared equals 4p times x minus 1. And so we need to figure out what p is. And so there's 2 ways you can do this. That you can do this based off of the picture and knowing that p is distance between these 2 points. So, that is 2 when you're looking right there. The one thing that I would say to be careful about that is because, you have to make sure you get the right sign, because if it's open in the other direction, it has to be a -2. So that's one reason why I just always go back to the formula that we have here, the h plus p in this case, to make sure that I just get the correct sign of p. Because if you just always find that distance, you're always going to get a positive, and then you have to remember whether it's a positive or negative depending on which side it's opening. So I just always go back to the ordered pair for the focus. So h plus p is the x value for our focus. So that 3 is h plus p. So h is 1. So I can plug that in. And so make sure I plugged everything in right here. Oh, that's why I was like looking at it like I shouldn't get a negative. So I forgot to finish my plus sign. 3 minus 1 is 2. So we get p equals 2. So that allows us to finish this formula, basically. We plug that in for p. Get y plus 8 squared equals 8 times x minus 1. So if I go back to Desmos, now our vertex is 1, -8. Focus 3, -8. And then our formula, y plus 8 squared equals 8 x minus 1. So, looks like my picture. We've got our vertex, we've got our focus, and it's opening, curving around that focus. Any questions? Okay, well, I'm going to skip my next example. I'm going to go to this one. So and that way I'm going to just skip ahead. So that way, if I get done early, I can answer the questions about the application assignment. So we've got the vertex here is 1, 2. And in this case, we're being told what the directrix is. So we're not given the focus. So now we've got a different piece of information about our parabola. So I'm going to draw my picture, and I know that our vertex is 1, 2. So just kind of sketching out it's somewhere there. And the directrix, so this is the equation of a line that our parabola is kind of going away from. So I draw my directrix like it's sort of like the line for an asymptote. I kind of draw it dashed. So that's the line y equals -1. So the parabola curves away from the vertex or away from the directrix. So that means my parabola has to go up away from that flat line. So it's telling me because we've got a horizontal directrix, this means that this is a vertical parabola and that my parabola is opening up because I have to curve away from the directrix. We don't cross the directrix when we have a parabola. So I've got this drawing now, and knowing that this is a vertical parabola, the formula is x minus h squared equals 4p times y minus k. And we have the vertex, so we have h and k, so I can plug those in. So that's x minus 1 squared equals 4p times y minus 2. So we need to find p, and p is the distance between the vertex and the directrix. So we don't need the focus. Before, when we were given the focus, p was the distance between the focus and the vertex, but it's also the distance between the vertex and the directrix. So we don't need to go and find the focus. The directrix is enough information. So I'm going to go to my little thing here. I've got a lot of things highlighted. Let me erase all of this. And so I've got the formula for directrix, y equals k minus p. So that's what I'm going to use. The fact that we have an equation for the directrix, it's k minus p. So what that means is that we've got this formula y equals -1, and that is equal to k minus p. And so k is the k from our vertex, so that's 2. So we have -1 equals 2 minus p. So now we just need to solve for p. So if I subtract 2 from both sides, I get -3 is equal to -p, which then gives you p is equal to 3. And so that is the distance. If we're up at 2 here and -1, that distance between 2 and -1 is 3. And you want it to be positive because positive means we're going up. So we've kind of verified that we have the correct sign, and with our picture, the value of 3 makes sense here. So then you just need to plug it in. And so this will give us x minus 1 squared equals 12 times y minus 2. So when you're checking your work and you're not given a focus and you're given a directrix, You can still do that in Desmos. So our vertex here is 1, 2. And what I do for Directrix is I literally put in the formula and then I click and hold on the colored part here, and that will allow me to make it like dashed. So that kind of helps me remember that that is the Directrix as I make it dashed. And then I can put in the formula that I got for the equation. We have x minus 1 squared equals 12 times y minus 2. And so we've got our vertex at the right spot, and you can see it's opening away from our Directrix to just kind of verify that it matches the picture that we drew and that everything kind of looks good. Because if you put in your equation and it was like the vertex didn't line up, or if it was facing down and it started going through, crossing your Directrix, that would give you an indication that you messed up. If you would actually put a negative here, let's say you forgot to divide by the negative. If you saw something like this and it's going through your Directrix, that tells you, oops, you messed up. So that's a kind of a check that you can do here, is just to make sure you're not crossing it. It should be going away from it. Any questions? Okay. So I do actually, I have one where we're finding the equation and we are getting it through a point, though. I don't know if this is actually the question, like what exactly you were asking about earlier about if you're given a point. Because it's not really worded the same as like the questions on the application assignment, but this is kind of similar, I guess, in a way. You're not really plugging in a number to solve for something else, but you are given like where the vertex is, and then that it passes through a point. On the assignment, you have to decide whether it's a vertical parabola or horizontal, kind of based off the context of what you're looking at, what you're trying to, like the road, you have to kind of decide is it vertical or horizontal, the arch, that kind of thing. But here we're told that this is a vertical parabola, because really, if you're not told or you don't know which one it's supposed to be, you could write either equation and it would still work. So it's important to know which way it's supposed to be. So we've got our vertex here at -1, 6. So I'll just put that up here. So that's my vertex. And we have that it goes through the point -9, 2. So this is just kind of a sketch. This is not, perfectly to scale. But I have to go through that point. And because I know that it's vertical, oh, that was terrible. It's my vertex is not even really the middle. But because it's vertical, I know it has to go down in order to go through that point. If they had told us that this was like a horizontal, I might have instead driven it or drawn it something like this, where it's still going through that point, but it's just facing another direction. But they told us that it's vertical, so that matters on how you end up drawing your picture through that point. So that part's really important. So I know that this is a vertical parabola. So the formula is x minus h squared equals 4p times y minus k. And we've got the vertex, so we have our h and our k. So that's x minus -1. So it's going to be x plus 1 squared equals 4 times p, and then y minus 6. So your next step is to find P. You can only find P directly if you are given the focus or if you were given the directrix. We're given neither of these. So we have to find P by plugging in the second point that we have and then solving for P. So we need to plug in for X and Y, the -9 and the 2, and that will allow us to find P. You can't use that method if you're given a focus because the focus is not on that equation. So if you tried to use that method, if you were given the focus, your equation would be incorrect because it only works for points that are on this actual equation. So since it's actually going through -9, 2, we know it's going to be on this equation, so we can find P this way. So the X value is -9. So instead of X, I have -9 plus 1 squared plus 4 times P, and then Y is 2. So it's going to be 2 minus 6. So we get -8 squared equals 4P. 2 minus 6 is -4. So you get 64 equals 4P times -4. So that's -16P. And then 64 divided by -16 is -4. So we get -4 is equal to P. So we can find P this way by plugging in another point that's on the parabola. And then that will allow us to give our final equation. X plus 1 squared equals 4 times P. So that's 4 times -4 times Y minus 6. Or X plus 1 squared equals -16 times Y minus 6. So here, when you're checking your work, like we're not given a focus, we're not given a directrix. I've got my vertex, which is -1, 6. I can just plot the other point, -9, 2, and I want to make sure that my equation goes through that other point, which is over here. So I've got X plus 1 squared equals -16 times Y minus 6. And so you can see, okay, we've got our vertex and it is going through our point right here, -9, 2, and it's a vertical parabola. It's got the correct shape, so you can use that to kind of double check yourself. Are there any questions? Is this actually similar to the question that you had early? Was that you, Brady, that was asking?
Yeah,
Okay.
I had already plugged that point that I thought I'd gotten. I graphed it all first and then I double checked it with Desmos. I just didn't know if there was another formula that I had missed.
Okay. So yeah. So I initially misunderstood your question. I was indeed going over something similar to that. So but yeah, this is the only way to do it. That I don't know of any other tricks.
Okay. All right. Perfect. Thanks.
You're welcome. Are there any questions on stuff on the assignment that I can answer since I've got like 5 minutes?
I only have one other question, and it had to do with the hyperbolas and how if I have a microphone, and it's kind of like I did in my discussion, I talked about Loran and how we locate ships and things like that. My question is once I plug all those numbers in for the speed and the distances, the point that I come up with, because basically we're kind of like creating almost like a grid or a graph to where I can tell where that point is based on its position data. Do I just plug that point in for A and B? Because they went over some exercises in the book, and it showed us how to get those, about where those, how to plug in those for those functions and get the two hyperbolas. But I never did see where it talked about if to know exactly where that point is.
So we don't have enough information to find the exact point. We would need like a third person. So your answer for number 5 is going to be just the equation. All you can say with 2 pieces of information is it's somewhere along either one of these branches. And you can tell which branch it is in regards to like where you are, who hears it first. Sure. But you don't have enough information. You would need a third microphone or a third person or something to kind of, that's why they say it's triangulation, you know.
In Loran, that's what you had to have, that third other receiver. So
yes. So you will not end up with an actual ordered pair. All you can say is I know it's somewhere along one of these branches of the hyperbola.
Okay, great. Thank you.
And that's fantastic that you brought up Loran and that you have experience with that, because like that is not my area of expertise. And I know they used it, and I've done some research to try to figure out how to explain this particular problem and how it works, but I have not. You probably explain it better than I do, having worked with it.
Yeah. Well, thank you very much.
Yes, you're welcome. Are other questions? Okay.